Aloha and welcome. In this lesson, we're going to be talking about the AD converter, the analog to digital converter. And here is the project, Chapter 9, AD converter. And we're going to be doing project 9.1, reading the voltage of the potentiometer. So we're going to need to learn first what a potentiometer is. I've got a great video for that. I'm going to be including in below. And I've got another site that I'm going to link as well in the video below that will give you a little bit of a better explanation than this PDF does. But here's essentially what we're going to need for this project. We've got our usual suspects up here, but we're also going to have the potentiometer, the rotary one. We have 3 of these, I believe, in our kit. You'll probably notice that the legs are a little bit messed up on some. You can straighten those out pretty well, but you're going to be plugging that down onto the board with the actual turn, the stick here facing you. And you're going to need 3 jumpers, maybe a medium to long size one, a medium, and a small. So let's see, the knowledge that we're going to be going over here is the analog to digital converter, the ADC converter. You've got resolutions and channels that we're talking about. The Pico uses the RP2040 chip. It's got a 12-bit ADC resolution, which means you can go between the numbers of 0 and 4095. That actually gets interpolated up to, the MicroPython firmware interpolates that up to from 0 to 65,535 because most other ones have that type of 16-bit resolution. So it does that automatically for us. So you don't have to worry about matching or mapping up the 0 to 4095 to the 0 to 65,535. So that will be done automatically by MicroPython for you. So what that's going to do is it's going to allow you to take your analog voltage range, which is 0 to 3.3 volts, and you're going to be able to take that wide range, and you're going to be able to spread it up over the 65,535 the 65,535 units of the analog signal. So if we look at it, it comes out to like this. So you've got 0 to 3.3 from 0 to 3.3 volts, and you're going to be crossing that across 65,535. Technically 65,536 values if you include the 0 there. So you can get the ADC value by calculating your analog voltage divided by 3.3 times 65,535. So we've got 5 ADC channels on the Pi Pico. They're going to be ADC 0, 1, 2, 3. But here's the thing about it. Well, first of all, that's GP, the general purpose pin 26, 27, 28, and 29. But you've got 29 that's used to measure your power for the Pico board, and you've got ADC4, which is used for the built-in temperature sensor. So you're not going to be using those 2. So we're going to use GP26 in this project. So the ones that you're really going to be able to use in general are going to be your 3 channels of ADC 0, 1, 2, which are going to correspond with the pins 26, 27, and 28. So component knowledge, potentiometers. I've got a good video that I'm going to link below that will go into the details of it, but just understand that with a potentiometer, you have a way of linearly increasing your resistance across 2 different values. So if you have a 0.1 and a 0.2 here, and you introduce this element here, 3, this is a linear one. You can actually use the slider to go back and forth. You can increase your resistance or decrease it depending on which way you go. And it's like having a resistor that's variable. So we're going to use a rotary version of this. So instead of having a slider, we're going to have the little the turn knob. So the knob itself is going to give you the ability to do the same thing here. But it's a linear process, and that's what you need to understand. It's going in well-defined increments as you go in one direction or the other. So if you want to know the symbol for it, use the symbols for it right here. But we're going to be using this rotary potentiometer shown right here. And actually in the video right there, you'll see the piece. These are really rudimentary. But anyway, let's go ahead and take a look at our diagram. we're gonna use pin 26. We're gonna go to the device, and we're gonna connect it on the middle pin. So here, look, you've just got power running to your power, which is going to be on your right side. You're going to have your ground going to the left side, and then your ADC pin is here in the middle. So your ADC pin is going to pin 26. So that is what we're going to set up. So let me go ahead and switch back to our. Well, actually, before we do that, let me pull up the code for this as well. So the code. We've got from machine import ADC and pin, import time, because we're going to do sleeping, obviously. So we're setting up ADC on pin 26, which we pointed out. We're going to go over an infinite loop. We're going to go ahead and we're going to read our value which is set up on pin 26. Once we get that value, remember our math we had back there, we're going to divide it by 65,535, multiply it by 3.3, and that's going to give us our values. So then we plug in our voltage and our ADC value there. So so that gives us what we want. We'll print that out and we'll sleep and we'll go ahead and read the value again. We're just going to go through and keep on reading it. So that's going to allow us to take our potentiometer, our little dial there, and figure out what value we get from that. So without further ado, let's go to our video. And here is our nifty, neato little project. So this is the potentiometer right here. We're going to set this up so that this, this points right at us. So let me go ahead, and to make it easy, why don't you go ahead and put it into the rail close here. And then once you put it in there, look where your, go ahead and look down and see where your pins are. So plug that down. Once you plug that down, let's go ahead and take the near one. We're going to set up our ground first, because our ground is going to be on the, it's going to be on this side. So when we look here, where is our pin? Our pin's going in here. So we take this, put it there, bring it over to ground, the black one right here, boom, we've got that done. We're 1/3 of the way, yay. So then we take our middle-sized one, and we're going to run this to our actual signal. So we're going to do this to ground to pin 26. So I'll put this in the middle. This will go over to pin 26. And pin 26, as you can see, is over here. I hope I've got that right. So pin 26, we've got that. So now we're going to take our power and we're going to run that. Let's see, make sure I've got it in the right one. This is going to go here. So it goes from here over to 3.3 power. And there we go. So that is the wiring. Let's take a look at it. Make sure we've got those things lined up on the pins. They are. We've got, then over here, we've got ground. We've got our 26 pin and our power down here at the end. So everything looks to be plugged up correctly. So now I will simply go over here and plug this in and smell for bacon. Nothing going. We're not burning anything up. So let's see if I can shift this in a way that makes it look a little bit better. Okay, that makes it look nicer. I'm sorry. Yeah, this is different because I've got my iPhone taking this video, so that looks a little bit more sightly, I guess. Okay, so now let me go and share my screen, and I will pull up our code editor. And with the code editor, we'll go ahead and run this. Pico is connected, we'll run it. And notice that we're getting this constant value, so it's 3.3. Notice how it does slip down a little bit, so that, if you look at our potentiometer here, it does, if I go and push it a little bit to the side, well, hold on, that's the other way. So if I push it to the side, it may hold the contact, but it's not precise. So it comes darn close to it, but now what I'm doing is I'm holding the connection in with my thumb, or putting the finger down. I'm turning the potentiometer all the way over to try to keep it as flush as I can. But if I let go of it, sure, it's going to come with a little, bit of imperfection there. So it is an analog signal. It's not exact. So let's go ahead and slowly turn it to the left. And as we slowly turn to the left, notice we're going down. And notice those are very, very big, differences in numbers as we go down. So we're able to get different gradations of precision, but we're going to go all the way down to, let's see how far down we can get it, almost to 0. So this is the range that we've got. We've got that 0.01, almost 0.02 volts. And then we use our potentiometer. We can go all the way up and get it to the maximum of 3.3. So there we go. So you can see, an analog signal isn't the cleanest. It's not the, it's not perfect like digital, which is, 0, 1, on and off. You've got that range. So as we go ahead and tilt down, we go and we get our different values. But this is the analog world. And as you can see, as we slowly go up, it's not going up in even numbers. There's no, it's going up, but it's going up in, little dribs and drabs as we move, because, our motions there aren't perfect. So that analog to digital, or that analog, it's reading whatever we're at there. So anyhow, I hope you've enjoyed this. This is a potentiometer, and this is, it's a lot of fun to play with things like these and see, how do you connect and get signals that, that take things from the real world, which is analog, and convert them into things that we can understand in the digital world. So this works, right now we're doing a potentiometer. We can get readings for like, temperature sensors. We can get readings for gas, sensors and things like that that are going to be giving us an analog reading, and we can translate that, using the ADC into some type of digital information that makes sense to us. So anyway, that's our example. I hope you've enjoyed it. And now we'll go into, I think it's 10.1 next. So hope you've enjoyed. If you have any questions, send me your questions. I'll be happy to help. Have a great day.